So next one we have node voltage method. Also known as nodal analysis, right? So before we are discussing about this one, right? So let us assume that something like this. So let's say its value is RA. Okay. So let us assume that, so this side, the potential is V1. So this side, this potential is V2. Right? So now assume that, so this is the current. The current direction is something like this. Okay. So now tell me, so what is the voltage across RA? Or what is the current through this RA?
V1
V1
minus
minus V1 by RA. V2 minus V1 by RA.
V2 by RA, right? This is the current, right? If you assume that this is the current, agree? Agree? If
Yes,
this
sir.
is the case,
Yes, sir.
so now tell me what is I1?
V2 minus V1 by
V2
RA.
minus
V2
V1 by
minus
RA.
V1 by RA, right? Okay. This is the fundamentals, right? So when you are measuring the voltage, we will measure from higher potential to the lower potential. Okay. So usually this lower potential will be taken as the reference with respect to this lower potential. So this is it, this much of higher potential. So these are the basics, right? So this is some prerequisite. So for this, right? So in node voltage method, for example, if you have an example, something like this. I'm erasing this. You have some circuit, something like this. Say it is VA and this is VB. Say this is R1, R2, R3, R4, and R5. Okay. Right? So now we will apply by using this node voltage method. So we need to find out the current or voltage across a particular element or all elements. So that is our objective. Right. So here node voltage means loop current method means we are dealing with currents. Equations are in the current form. So now this voltage in this node voltage method, so this will be in the voltage form. Okay, so this will be in the voltage form. So here you have unknowns. Earlier we have this current form, right? You have I1, I2, I3. So now you have V1, V2, V3. So that is in the voltage form. Okay. So in this method, so what we have to do is, first thing, we have to choose a reference node. We need to choose a reference node to which all the node voltages can be referred. We need to first choose a reference node from which you need to refer all the other nodes, right? So before that, so how many nodes are there? What is node? First thing, so
Four,
node
sir.
is the point
Four nodes,
where
sir.
the current or junction where the current is splitting, right?
Yes,
Where
sir.
the current is splitting. So where exactly the current is splitting here?
Two.
So there are four
So
nodes.
here there is no current splitting, right? So here,
First node. Yes, sir.
Yes, sir.
the current
Only
splitting
two,
is
sir.
taking place. So here, but here there is no current splitting,
sir.
right? Okay.
Only
But
two,
this
sir.
entire thing, so this is one node only, right? Agree? This is one point only. Clear? You accept this?
Sir, one
Sir.
second.
Yes, sir.
But current comes from R2 and R4 also to the same
So
point.
this diagram can be drawn like this, right? Both are same.
Yes, sir.
Yes, sir.
So
Because
this
they
is
are all
single node only, right? This is for our convenience. We drawn this. Correct? Agree? This is for our convenience. It is drawn right. So how many nodes you have?
Two nodes.
Two nodes. Two nodes,
Three
sir.
nodes.
Three.
Why two nodes? This is the entire thing is one node, right? This is three nodes. So first thing is identify the number of nodes. Next, select a reference node. Right. Select a reference node. From that, the other nodes can be referred. So here, which one is suitable for reference?
The third one.
R1,
At
R2,
lower-
R3.
Bottom one, right? So this bottom one may be suitable for reference, right? Agree?
Yes, sir.
Okay. So assume that, so this is node A, and this is B, and this is C. Right. Okay. The first point is identify the number of nodes. Second point is choose a reference node. From all the other nodes can be referred. All the other nodes can be referred. So in this, most of the cases, not only this, most of the cases, usually the bottom one may be the suitable point for the reference. Right. So assume that, so this voltage is 0. So assume that that voltage is 0. Or in other words, so this entire thing is grounded. Clear? Is clear?
Yes, sir.
So once this is done,
That's the zero potential one. Can you please repeat again?
we assume that this is zero potential. With respect to that, so next step, if you explain the next step, you'll understand, right? This is A, this is B, right? So next step is remaining nodes. We have one A node and B node is there, right? So for remaining nodes, assign a voltage with respect to this ground. So this voltage is VA. Right. So this voltage is VA. This already, change this one. This is V1. I assume this is V2. So this voltage is VB. So with respect to this ground, right? So this voltage is VA. With respect to this ground, this voltage is VB. Is clear?
Yes.
Okay. So first thing is choose a reference node. So assume that the reference is grounded, right? So with respect to that, the remaining nodes are labeled with VA, VB, VC, and so on. Clear? It's clear?
Yes.
Yes.
Right. So what is the next step is? So we need to choose the currents. Maybe you can sign. So this is next step. Once it is done, every node we need to apply KCL. Every node you need to apply. There are two nodes are there, right? This is VJ, VB. So that is the voltages. So you need to apply KCL. So for that, so assume that this is the current flowing in this branch, and this is the one, and this is the one. So these are the assumed ones. Clear?
Yes.
So now tell me, at node A, if you apply KCL, right? If you apply KCL, so now tell me what is the current through this one? What is the current? For example, this is I1, for example, and this is I2, and this is I3. So what is I1?
VA minus V1
VA minus
upon R1.
V1 R1.
Yeah. So this is the voltage source, right? VA minus
So
V1,
VA minus V1 upon R1.
VA minus V1 upon R1, right? So what is I2?
VA by R2.
So
VA by R2.
VA minus 0 by R2.
VA minus 0 by R2 more precisely. Plus
V3 minus VB by R.
VA
What is
minus VB by R3.
VA minus
VA
VB upon R3.
VB upon R3. So this entire thing is equal to 0.
0.
Clear?
Yes.
Right? Similarly, so this is one step is over. Similarly, for B, node B, right? So node B, at node B, if you apply KCL, so again, so what is the next thing is, again, you need to give the directions, right? So this is one current and this is the outgoing current, assume that. So this current, either you use this one or, right, or you can use this one. You can separately mark this one. Okay. So now tell me at node 2, if you apply these equations, so what is this current?
VB minus VA upon R3.
VB minus VA upon R3, that is the first one, plus
VB minus V2
VB
upon
upon
R5.
R4.
VB by
minus 0.
VB
VB minus
minus
0
0 by
R4.
divided by
4,
R4.
right? Plus next thing,
V minus V2 by R5.
VB minus V2 by
V2
R5.
R5. Okay. So y minus 5, because this is plus minus symbol, right? If it is in the opposite polarity, it will be VB plus V2. That's all. So this is equal to 0. So how many unknowns are there? So this VA and VB. So these two are the unknowns. Okay. If we assume that this V1, V1, V2, R1 to R5 values are already known to you. So these two equations are used to solve the expression, or us to solve these voltages VA and VB. Right. So once you know these voltages VA and VB, so rest of the things is to calculate the currents. This clear? Or can I repeat?
Okay, समझा sir.
Good. Very simple. So first thing is identify the number of nodes. Right. Identify the number of node. After that, you have to choose a reference node. Choose a reference node. So we assume that the reference is, our reference node is at 0 potential. Right. So rest of the nodes we have to label with voltages, say from VA, VB, VC, or V1, V2, V3, something like that. Right. At every node, we need to apply KCL. By assuming the current direction, we need to apply KCL. Right. So once this is done, so you will get different equations depending on the number of node voltages. These are the node voltages, right? So that's why this method is known as node voltage method. So depending on the node voltages, unknown node voltages, this is already, we assume this is 0 voltage, right? So that means you left with VA and VB. So depending on that, so you will get equations, the same number of equations. From that equations, by solving those equations, you can find out the values of node voltages VA and VB. So once you know the node voltages, you can easily calculate the current, right? For example, if you want to calculate this current I3, so I3 is simply VA minus VB by R3. That's it, right? VA minus VB by R3. So that is the current that is flowing through this R3 ohm resistor. So if you solve a problem, so it will be more clear. Yeah, that's all. So now, by using node voltage method, so you need to obtain, right? You need to obtain the, for example, current through. That is the question. Current through this I4 ohm, I6 ohm, and I2 ohm. So you need to find out. So that is the problem, right? The first thing is, what is the first thing? So how many nodes are there? How many nodes are there?
Two.
Three, sir. Three nodes are there.
Three nodes, right? So
Sir.
three nodes are. Am I audible?
Yes, sir.
Yes, sir.
So 3 is suitable for reference. There is nothing wrong if you take 1 is the reference or 2 is reference, right? But structure wise, or the problem, if you see the structure wise, if you take 3, so that means there will be no much confusion, right? Okay. So what is the next step? Once you set the reference, so which is you assume this is grounded. So what is the next step is?
So
What-
making 3 potential 0.
Hmm?
Making 3 a grounded, right?
Yes, yes. So in the rest of the things, we have this voltage, right? So assume that this is V1 and this voltage is V2. Clear? So this step is over. So what is the next step? What is the next step?
Sir, KCL apply on each
KCL
node.
at each node, right?
Take current.
KCL at each node by assuming the current direction, right? If you see this one, so how many are connected to this node? A 2 ohm resistor, a 4 ohm resistor, and a 5 ampere current source. Okay, so this current source direction is already given, right? So this is like this. So rest of the things we have assumed that this is the outgoing one. So this is also outgoing one. So now apply KCL at node A or node 1. So what it results?
Sir, 5 equals to
Yeah, 5 equal to
V1 minus V2
V1
upon
minus
4
V2 upon 4 is plus
V1
V1 upon
minus
2
V2
ohm.
upon 4
ohm
plus
plus V1 minus 0
V1 minus 0 by 2.
2 ohm.
So this is equation 1. Similarly, KCL at node 2. Okay, KCL at node 2. Yes.
N is equal to V2 by 6 plus V2 minus V1 by
We'll
4.
come to that. So first thing is similarly, so how many are connected here? 4 elements are connected, right? So 4 elements are connected, right? So you have a 5 ampere source, a 4 amp resistor, a 6 ohm resistor, and 10 ampere current source. So 4 elements are connected. Okay. So in this, if you notice that, right? If you notice that, so this is the current direction is already given. So this is the one, right? So here, this is the one. Agree?
Excuse me, sir.
So here, if you notice that this direction,
I am.
you are already chosen this one. Okay. So that means I follow the same one.
Sir, at KCL at node 1, will it be minus 5 or 5, sir? In the equation?
It is on the other side, right? Incoming currents are equal to outgoing currents. So
Yes,
this
sir.
5 is the incoming current, right? And these are the outgoing currents. Okay, agree? What KCL states that incoming currents are equal to outgoing currents, right? Or sum of the currents across the loop is 0. So in that you need to take minus 5. So now you need to add plus here. Plus
Yes, sir.
here. So that is equal to 0.
Yes, sir. Thank you.
So incoming currents are equal to outgoing currents. If these two are the incoming currents, and this this 5 ampere is the incoming current, and 4 ohm resistor and 2 ohm resistor, we assume that those are the outgoing currents. Okay. So now there is some conflict here, right? So when you are choosing this 4 ohm, so you are already assigned, when you are assigning the node 1, you are already assigned this one. So this is the direction. Either you use this direction, same direction, or you can use your own direction. But the thing is that, so when you're writing that, so this the current may be on incoming side or outgoing side. See, we must take care that. Okay. Right. So for your convenience, I assume the same direction, and this one, so this is the outgoing current. I assume this is the current direction. Okay. So this is the only thing we need to label the direction. So I assume this is the outgoing current. So now tell me the equation.
So
What are
10
the
is
incoming-
equal to.
What are the incoming
10 is
currents? 10 equal to, right?
So 10 is equal to, sir, 5 plus, sir,
5 plus
V2 minus V1
sir, so
plus
V2 upon 6 ohm.
V2 upon 6.
V2 upon 6
Yes.
plus
What is the
V2
other
minus
incoming current?
Some
V2 minus V1 by 4.
What
V1
is the
minus
other incoming
V2.
current?
V1 minus
V1
V2
minus
divided by 4.
V2 by
minus V2 by
4. So that is the incoming current, right? Agree?
yes.
Okay. So this is one way. This is second equation. Or if you know that if this is creating confusion.
Sir, once again explain second equation, sir, please.
One second. Yes, what you're saying?
Second equation, sir. How is again once again explain V1 minus V2 by 4
Yeah.
and plus 10 is equal to.
Okay. So here in second equation, there are 4 elements are meeting, right? 2 current sources and 2 elements, 4 ohm resistor and 6 ohm resistor. Agree?
Sir.
Right. So now this current source, this direction is already given. So this upward arrow, so that means this is incoming, and this one is 5 ohm is the outgoing, right? Okay. So now, so if you come to this 4 ohm, so 4 ohm, you already labeled this current. So this is the current, you already labeled that one, right? Either you will use the same one, or you have your own thing. Normally what you are saying that this is the outgoing current, right? We assume that the current is outgoing. So here also you can use this is the outgoing current. Okay. So that thing you can use, or if you use this is the current, you already assumed that. Why do you assume again? So if you assume this one as outgoing current, it will sometimes it may be contradictory. So to avoid or simplicity, I already assumed that. So why do you assume again? So this same direction I have chosen. So now what are the outgoing currents here? This 5 ohm is the outgoing current, and this 6, this is V2 by 6 is the outgoing current, and this is the current, right? What is the current here? V1 minus V2 by 4 plus this 10 amperes. These two are the incoming currents. Now agree?
Okay. Yes.
Right. If we, for example, why to confuse, I also exude that this is the outgoing current, right? So instead of that, so here it will come. So what it will come here? V2 minus V1 by 4 ohm equal to nothing, not equal. This is equation 2. Okay. Clear? Agree?
Sir, you
So
said
now
V1
tell me
minus
what is V1?
Sir, V1 minus V2 by 4 is the incoming current. No, sir. Again, why have you written a V2 minus V1 by 4?
See, I changed the direction, right? I changed it to outgoing
Change, no,
current.
sir. Across single resistor, only one direction current will be flowing, not the
So
two
that's why
directions.
there is nothing wrong. Okay. So this equation is independent and this equation is independent. Okay. See here, I assume this is the one, and I see whatever, if you put that for that side or this side, there is no difference. So that is my point to that's why I'm emphasizing.
Okay, sir.
Okay. Right. So there, if you are moving this one, simply it will be V1 minus V2 by 4 will come. That's all. Okay. So I assume this is the direction. So this will be V1 minus V2 by 4. Yeah. So now tell me what is V1 and V2. Let's calculate V1 and V2.
V2 is 20 volts.
V2 is 20
V1
volts.
V1 40.
V1 40 by
40.
40 by 3.
40 by 3.
40 or 40 by 3?
40 by 3, sir.
Sir. 40 by
Okay.
3.
Right? I'm erasing all these. Right. So what you obtained here, so this V2 is 20 volts, right? That means this voltage is 20 volts and this is 40 volts. Okay. So now the question is, for example, this is question, right? 6 ohm and this is 2 ohm, right? So now tell me what is the current through this 4 ohm resistor? What is the current through this 4 ohm resistor?
5 amperes.
It's 40 by 3, right?
Amperes.
Okay. What is the current through this 4 ohm resistor?
5 by 3.
5 by 3.
40 minus 3 by minus 20 by 4, right? Agree?
Yes.
Okay. So how much you got?
5 by 3.
So
Sir.
minus 5 by 3.
Minus 5 by
5 by 3. Sir.
amperes. Okay, so that means this is the assumed direction, but instead of that, the current flowing in the opposite direction. But the actual current flow is like this. So what is the 6 ampere current? 6 ohm.
10 by 3 ampere.
By
20 by 3. 10 by 3 amperes.
So 10 by 3, sir.
20 by 6. So that is 10 by 3 amperes. Okay, that means it is positive sign, means that is in the same direction. So next one, what is V1? That current through 2 ohm resistor.
20 by
20
3.
by 3 amperes.
40 by 3
Same direction.
by 2, right? So that means 40 by 6. 40 by 6 amperes in the same direction. Clear? Agree?
Yes.
So this is how we will solve the problems. Okay, na? Okay, solve this as an example, your free time. So find the current through all the branches if these the current directions, if the current directions are given. So this is the first one, second one. If these are the current directions, so find the current through all the resistance, find the current through all the resistive elements. So do this at your free time. Okay. You noted this, right? If you noted this, so we'll move to the other example. I'm erasing this. So here Ix I need to give, right? So this is Ix. Right. So here how many nodes are there?
Is
Three.
3, sir.
3, sir.
Sir, 4.
Three or four?
Sir, 4.
4.
4.
So if you assume this is 1,
Four.
2, and 3, so this is 4,
Note
right?
that
So
down.
this one will be the reference node. Agree? What is the next step? So assume this voltage is V1, so this is V2, and this is V3.
KCL on V1.
Okay? Right? So this node, first thing we need to apply KCL. So this current direction is already given for this. So this is the one incoming current. So we normally assume for all the elements, so we assume that is the outgoing current, right? So this current is already given. So this is Ix that is already given, right? So now tell me, so what is the equation for this? What is
So
the
3
equation?
equals to
So
3
3
equals to
to V1 minus
V1 minus
V2
V3
by
divided by
2.
4.
V1 minus V2 upon 2.
3 is the
3 is
incoming
equal to
current, right?
V1 minus
So incoming currents
Yes,
are
sir.
equal to outgoing current. 3 equal to
Ix
V1 minus
V1
V2 by
3
IX
equal to Ix,
Ix also V2
plus
Ix plus
Ix
plus
plus
V1
V1
minus
minus
V3 divided by
V1
V3
4.
minus V3
upon 4.
upon
4.
good. Right. So in this also we can identify Ix, right? What is Ix?
V1 minus
V1
V2
minus
by 2.
V2 by 2.
V1
Good.
minus V2.
V1 minus V2 by 2. Right? Yeah. So next node 2, this is one equation. So this is other equation. At node 2, so apply KCL.
Sir, Ix equals
So
to
how many,
Ix
these are the
equal to-
elements, right? So this is the outgoing element. So this is the outgoing element. So this Ix direction is already given. So that means I'm retaining the same. I'm using the same direction. So this is Ix. So now tell me. So what
Ix
are
is
the
Ix is
equal
incoming
to
current?
equal to
V2
V2
by
minus V3 upon 8
V2
plus
by 4.
V2 upon 4.
V2 by 4 plus
Plus
V2 minus
V2
V2
minus
minus
V3 by 8.
V2
V3 by
upon
8.
8.
That's good. Right. So node 3. Node 3.
2
Ix is
by
equal to,
Right.
sir, V2 minus V3 upon 8 plus, sir, V1 minus V3 upon
So
4.
this is the outgoing current.
exactly correct.
So this current
V3
direction we already assumed, right? So I'm retaining the same thing. Right now tell me what are the incoming currents?
sir V3
Sir, at
minus
node 1,
V2
sir,
upon
we
8.
already took that in upward direction, sir. So then at
Exactly,
V3 also,
sir.
sir, it will be in that direction only.
Yes.
Sir, 4 ohm current, the above resistor, we have already taken the current to be clockwise, sir. So we can
Where,
take
which
it
one?
at downwards only. The
This
above
one.
4 ohm resistor.
This one.
Yes. No,
So
above,
how you
above.
know that this is upwards or
Above.
downwards?
Sir, the uppermost loop, sir, the uppermost loop. In that,
This
sir, we
means?
already assumed in clockwise direction, sir.
Okay, this one you're talking. Okay. This is the one, right?
So,
Okay.
so we
Sorry.
can
Yes,
take
sir.
the
So, sir, we can take it
Yeah,
as
got it.
in downward direction.
This one.
downwards.
This is the one, right?
Yes, sir.
It flow like
Yes.
this. Okay.
Yes, sir.
Yeah. So now tell me. So these two are incoming
Sir,
currents, right? So
2
V1,
Ix is
V2,
equal to, sir,
V2 minus, no, V2 minus V3 by 8
8 is equal
plus,
plus
Plus
V1 minus V3 by 4
right?
equal to
is
2
equal to
IX.
2ix.
To Ix.
The direction doesn't matter. No?
Hmm.
Direction doesn't matter. We could take downwards or upwards.
Direction doesn't matter. I already discussed
Yeah.
it, right? Direction doesn't matter. So how you are taking or how you are, just for I'm retaining, you already assumed that. So I'm just for the sake of my satisfaction, I'm using the same thing. I'm using the same direction only. Okay.
So sir, in V3, we could take upwards also, right?
We can take upwards, but the equation will change. That's all. Instead of the right hand side, it will go on the left hand side. Instead of V1 minus V2, you will make it V2 minus V1. That's all. Okay. So this is for my satisfaction. So I already assumed this is the one, right? So why to choose again? Right. So that's why I'm retaining the same direction. So there is nothing wrong. That's why in the beginning I discussed there is nothing wrong. Either you choose this direction or that direction.
Okay, sir, got it.
Okay. So we also identify this Ix, right? So next step is you can solve for V1, V2 and Ix. V1, V2, V3, right? We have 3 unknowns, 4 unknowns are there. So 4 equations. So you just simply apply those. That's all. Clear?
Sir, if we get voltage also in negative, then also direction only is wrong. We have taken opposite direction, sir.
If this voltage is negative, right? For example, this voltage you got, for example, 10 volts. That means with respect to this one, this voltage is minus 10 volts. That's all.
Okay.
See here, for example, you V1 you got as minus 20 volts and V2 you got as minus 10 volts. Okay, for example. So what is the current through this Ix? What is Ix now? Ix is
Sir, it
always
will be
same,
in the
right? V1
leftward
minus
direction.
V2 by 2
So it
only.
will be in leftward direction.
Whatever, right? See, this
I am
Ix is always V1 minus V2 by 2 ohm only, right? So what is V1? So minus 20 minus of minus 10 divided by 2. How much it is?
Plus minus 5, sir.
Minus
Plus
5.
5.
So you assume this is the direction of Is, but actual practice it is flowing in the opposite direction. Okay. See, your formula is remain same irrespective of V1 positive or negative. It's clear? No confusion, right?
Yes.
Can we move forward?
Yes, sir.
Okay. So I have one more example. I will give it to you now. This is 0.5 into I. This is 12 ohm. 6 ohm. This is 6 ampere. Right. So this is 6 ohm again. And this is 12 I. This is also 12 I. And this is 18 ohm. So where this I is, so this is I. So we have two dependent sources. So both are controlled by same I only. So to avoid confusion, I will write Ix. So this is Ix. So this is also Ix. I noted this. Done?
Yes, sir.
yes, sir.
Solve this one or in either ways. So find the current through this 12 ohm resistor, 6 ohm resistor, and this 6 ohm resistor, another 6 ohm resistor. Okay. Right. So next we have, so what Similarly, we studied about conventional circuits. After that, we studied the dependent sources. What is the next thing is after in mesh analysis, you studied super mesh, right? So here also we have super node. So that now we'll study. So what is super node and when we have to use that super node? So that we'll study now. Say this is 2 ohm and this is 8 ohm and this is 6 ohm and this one is, say for example, this plus minus 5 volts. Top one is 4 ohm. This one is 10 ohm. Okay, right. So in this, so the question is find the current through these branches. So find the current through these 4 branch or 4 resistors, right? So now tell me how many nodes you have.
Four, sir.
How many nodes you have?
4, sir.
4, right?
Four,
Including the reference. So
4.
this is the reference. So this is V1, so V2 and V3. Right? V1, V2 and V3. So next step, what is the next step?
KCL.
What is the next step? KCL, right? What is KCL, right? So apply KCL here.
But here node 2 we cannot apply KCL, sir, because of that voltage source.
You cannot apply
Yes,
voltage
sir, we
source.
cannot apply voltages.
We cannot
So can
apply
you apply here? Can you apply at V1? This node, can we apply KCL? This node.
Yes, sir.
Can anyone tell me what is the voltage V1 straight away?
10, sir.
Good. See,
10.
this is ground, right? So that means this voltage is already 10. So V1 is always 10 volts. Okay. V1 is always 10 volts. Because there is no, for example, if a resistor is there, so you cannot tell that, right? Okay. There is
And
no
V2
resistor.
minus V2 minus V3 is 5, no, sir?
V2 minus 5 equal to V3.
Yes.
Oh, sir, V2 minus V3 is 5,
V3
sir.
is equals to 5.
So that will come. Okay. Right. So straight away you can write 10 volts. Actually, I forgot to include a resistor. So that's why this is happening. I will include that. It's 10 volts. Say this value is 5 ohm. Okay. Right. So now can we apply KCL? So this is the one. So this is the current direction. And this is the current direction, right? So what
Yes,
is
sir, we can
KCL?
apply now.
KCL at node 1. What is KCL at node 1?
V1 minus V3 by 4 equals to
V1 minus
V3 by
V3
4 equals
4
to
equal to, yeah,
V1 minus 10 by 5.
y plus V1 minus 10 by
0.
5. Good.
10.
Plus what is the other element?
V1
V1
minus
minus V2 by 2.
divided by 2.
V1 minus V2 by 2. V is all are outgoing currents, right? So all are equal to 0.
Yes,
So next step, so can we apply at node 2? Can we apply KCL? Right. So here, if you assume that, so this is, you have only the current source is connected between, so voltage source is connected between this node and this node.
Yes, sir.
Right. So now what is the current here?
V2 minus V3, sir. V2 minus
V2 minus V3 is the voltage, right? What is the
voltage, sir.
current?
Yes, sir.
What is the current?
No current, sir.
No,
So there
we
is
don't
no
know.
current, right?
No current.
Right. So in this case, you cannot apply KCL at node. This node you cannot apply. So this node also you cannot apply KCL because you don't know what is the current that is flowing through this 5 ohm resistor. You don't know the current. So under this case, so we will combine these two nodes. We will combine these two nodes and we'll form a node, so which is known as super node. We will form a node, so which is known as super node. Clear? So whenever in between two nodes, if you encounter a voltage source, right, a voltage source without any resistor, right? So in that case, you cannot apply KCL because you don't know what is the current that is flowing. Right? If you have a resistor, for example, in this case, so you have a resistor, right? So in that case, you applied KCL. So in the same case, if you have resistor is there, so under this case, you can apply, right? So this is the particular case, you know this voltage, so that's why you applied this KCL. So if it is encounter, for example, you have something like this current voltage source is there, you cannot apply. So we assume this is a super node. So what is the next step is, we will apply KCL at super node. KCL at super node. So here also, so we assume that this V1, V2 retains same. So how many elements so that are connected to the super node?
4 elements.
4, sir. 4
Which
elements.
element? So this one is connected to super node. So this is connected to super node. So this is connected. So 4 elements are connected, right?
Yes, sir.
Okay. So next step is assume the current direction. So this is already assumed, right? So this is connected here, and this is here, and this one, and this is the one. These green ones are the current
Okay.
direction, right? So now tell me KCL at super node. So what is the current through this one? What is
So
V1 minus V2 upon 2.
V1 minus V2 by
2 is equal to
plus, so this is a
Plus V1
plus,
minus 5 by 4.
no, this is incoming currents, right?
V1
This is one
minus
is over.
V1 minus
This next
V3
one,
by 4.
current is only
what
one,
is
sir.
the other
Outgoing
incoming
current.
Sorry,
current?
V2 by 4.
V1
Plus
minus
V1
V3.
minus V3
V3
by
4.
4.
4
So this one is over, right?
Yes, sir.
So next, what is left? Outgoing currents.
is equal to V2 by 8, sir.
V2
V2 by
by
8. Good.
V2 by 8 plus
Plus
V3 by 6.
V3 by 6, sir.
V3 by 6.
by 6.
That's all.
And V2 minus V3 equals to 5, sir.
Yeah, we'll come to that. So this is one. This is second equation. This is the first equation. At super node, we have relation between this V2 and V3. What is that relation? So this V2 is upper voltage, right? This is positive
V2
plate.
minus
So that
V3
means
is
V2
equal to
minus V3 equal to 5 volts. This is the third one. Now solve these three. So you can obtain the equations, or you can obtain V1, V2 and V3. Is clear? It's clear, or can I explain again?
Yes.
It's clear, sir.
Okay.
Can you explain again
Fine, sir.
the super node part? The
Super
super
node
node.
part, right? Yeah.
Yes, sir.
I will erase first. So you know when to consider supernode, that you understand, right? So when to use supernodes, that you understand, right?
Yes, sir.
So next thing is, yes. So when there is a voltage source between two nodes, in that case you cannot apply. You don't know what is the current that flows through that particular voltage source. So in that case, we will apply super node. So this is super node. We assume that this entire thing is a single node, right? So this thing, so how many elements are that are connected? So this is the first element. This 4 ohm resistor is connected. This 2 ohm resistor is connected. This 8 ohm is connected, and this 6 ohm is connected, right? Agree? This you understood, right?
So
So now you need to apply KCL. For that, this is the current direction. This is one current direction. You assume the current directions. Either you can use the already using direction, or you can use it randomly. That is your choice, right? So this is the directions I assumed. Okay. So this is the incoming currents. So what are the incoming currents? So this 2 ohm is the incoming one. So this is incoming, and this 4 ohm is also incoming, right? So these two are the incoming. So what is this current? So this current is V1 minus V2 by 2 ohm. Agree? So this V1 minus V2 by 2 ohm plus. So this is another incoming current. So V1 minus V3 by 4 ohm. So that is equal to outgoing currents. So here this is connected to V2, right? So V2 by 8 plus this is connected. The 6 ohm is connected to V3. So V3 by 6. That's all. Clear? So now we have this super node. So this voltage is known to you, right? This voltage is known to you, and this voltage is V2, and this voltage. But in between, you have 5 volts, right? So therefore, you can write the voltage equations: V2 minus V3 equal to 5 volts. Yeah, V2 minus V3, so which is equal to 5 volts. Is clear?
clear, sir.
Okay. Right. So next we will move to other problem. I will give you one example problem. In mesh analysis, when you have a current source which is common, so we will apply super mesh. So in this, when you have voltage source which is common, we will apply super node. This is 20 volts, and this is 2 ohm, and this is 10 ampere, and this is 6 ohm, and this is 4 ohm. We have plus minus. So this is 3 Vx. This is 1 ohm, and this is 3 ohm, and this is your Vx. Right. So for this problem, so find out the current through all the branches, all the resistors. So how many nodes we have here?
4.
5.
Sir, 6.
5 nodes.
5.
Sir,
6.
6, sir.
5, sir.
this is one, right? So this is another one, this is another one, this is another one, and this entire thing is one, right? So why 6? Only 5, right? Agree?
Okay,
This
sir.
is
Okay, sir.
So this is V1, so V2, V3, V4. So which will form super node here?
So
V1,
the
V2,
one
and
between
V3,
V1
V4.
and V2.
V1 and V2.
V1, V2 will
V1
form
and
super
V2.
node. What is the other one?
V3, V4.
So V3 and V4.
V3 we have, that is also we have dependent current, dependent voltage source is there. So that is also forming a super node, right? So now you can write the equations, right?
Yes, sir.
Yeah, I have answers. So V1 we'll supposed to get 26.67 volts. V2 is 6.67 volts. V3 173.33 volts, and V4 minus 46.67 volts. Okay. Right. Clear? So try to solve this, an example. You can cross verify the answers. So you have any further questions?
So you have written the answer, sir?
Yeah, this one, V1, V2, V3, V4. Actually, this one I brought it from a test book. Okay. So these are the answers for V1, V2, V3, and V4. Yes, you have any question?
Will there be two super nodes here or just one?
Two only, right? See here. So this is one node, right? So this is one node. So this is a voltage source. A voltage source is common, right?
Yes, sir.
Okay. So here also, if you notice that between V and V3, there is a voltage source which is common.
Yes, sir.
Okay. This is also voltage source, right? But this is independent source and this is a dependent source. We already seen the problems in when we are studying the mesh analysis, when you are applying the super mesh. So whether it is a dependent source or independent source, if it is a current source, is common to two loops. So we applied super mesh, right? So here also, if the voltage source is common to two nodes, we applied super node.
Sir, while writing current through 3 ohm resistor, we can shall we write V1 minus Vx minus V4 by 3 ohms? Sir?
What?
Current through 3 ohm resistor, sir, upper above that, all above that. The top
3
one.
ohm resistor. This one,
V1,
yeah.
V1
V1
minus
minus V4. V1 minus
Vx.
V4 by 3.
Okay, sir. V1 minus V4 is the Vx, sir.
Yeah, V1 minus V4 is Vx. That is other equation.
Okay, sir.
Okay, we'll discuss again, no problem. If you have any questions, we'll discuss in the next class.
सर
Yes?
सर वो नीचे वाला जो रेफरेंस नोड माने तो एक बार बता दीजिए ना, मतलब चारों पॉइंट को एक साथ नोड कैसे ले लिया?
No, this is common meeting point, right? So this circuit, right, for my convenience only I had drawn like this, right? You can connect directly like this, agree? Okay?
Yes, sir.
So you can directly connect like this. Both are same, right?
Yes, sir.
Okay. For my convenience, so that it will show in some box kind of thing. So I drawn like this. So this is only one node only. Even though it looked like, see here, this is entire thing is one node only, right? Because there is no meaning to this line. Because it's just a short circuit line, right? So this entire thing is only one point. Because of my convenience, I drawn like this. But all the points are meeting, right? At one place.
Excuse me, sir.
Yes?
Sir, there is no specific restriction that we have to take the down part as a node, right? Like in other questions.
Yeah,
like in
that
the
is true. But see, if you see the problem, for example, if you assume this is the reference, okay, if you assume this is the reference, it will, if you assume this is V2, it was slightly confusing, right?
Yes, sir.
Okay, it is slightly confusing. So that's why in most of the cases, so we assume this is the reference. There is nothing wrong if you choose anything as a reference. But the thing is that it was slightly complicated.
Yes, I got that. Thank you.
Okay. So the good thing is that, for example, if you choose this one as the reference, for example, if you choose this one as reference, okay, so there is some advantage. What is that advantage? If this is the reference point, so what is this voltage?
Minus 20.
Minus 20, right? Okay, so that you can obtain. You know? But most of the cases, we normally use this bottom one as the reference. Some cases, what will happen, we have some advantage. So when you choose the reference value. Is clear?
Yes, sir.
Okay, any further questions?